Welcome to Summarize Science. Today, we're diving into how we can get drones to navigate complex, obstacle-filled environments at high speed. It's a huge challenge, but a new planning framework called Stitcher is making it possible in real time. As you can see from this image, it's all about finding that perfect, smooth path through the chaos. To understand why Stitcher is so special, let's look at the old way of doing things. Planners were often either very thorough but too slow, or fast but short-sighted, like only looking a few feet ahead. Stitcher's innovation is a three-stage architecture that gets the best of both worlds. Think of it like planning a road trip. First you pick the major cities, then you figure out the best highways between them, and only then do you plan the turn-by-turn directions. The first two stages are all about preparation and creating a smart guide for the final search. The system first identifies key waypoints, and then it calculates the minimum time it would take to fly between them using a simplified model. This calculation acts as a perfect hint, telling the final planner which paths are likely to be the fastest. This clever step is what makes the whole process incredibly efficient. The final stage uses this hint to perform a much more detailed search, stitching together complex flight maneuvers to create the final path. And the results are impressive. The researchers found that Stitcher was consistently faster than two other state-of-the-art planners. In some cases, it was over 400 times faster, finding a solution in just a few milliseconds. But speed isn't everything. The paths also have to be physically possible. Stitcher is unique because it can handle highly complex and realistic constraints, like the maximum thrust of each individual motor. This is something that is notoriously difficult for other planners to do in real time, and it ensures the planned trajectory can actually be flown by the drone without issue. To prove it wasn't just a simulation success, the team tested Stitcher on a real, custom-built quadrotor. They had it fly complex paths through several different virtual environments, like this obstacle course. The drone was able to follow the generated trajectories with very low error, demonstrating its real-world feasibility. So, to recap, the Stitcher framework is a major leap forward for three key reasons. It's incredibly fast, generating paths in milliseconds. It's more reliable, with a much lower failure rate than competing methods. And it's more expressive, able to create trajectories that respect the true, complex physical limits of the vehicle. This technology could unlock the potential for drones to perform tasks we've only dreamed of, from high-speed search and rescue in disaster zones to fully autonomous drone racing. It's a perfect example of how clever algorithms can solve complex real-world problems. Thanks for watching Summarize Science.